When we send the laser light into the syrup, we can clearly see the laser light path through in the colloidal solution, which contains a large of particles. The reason why we can see the light path is that these particles are big enough to reflect the laser light into our eyes. So we can use this phenomenon to conduct the following experience. Now we pour the water into the syrup at a certain speed. Because when we pour the water too fast, the angle of curve of light is too big. And then when we pour the water too slow, there is no different concentration of the syrup. And then we send the laser light into the syrup again. We can see a curved light is there. What causes this is that when we pour the laser light in certain speed, we are changing the concentration of the syrup and the index of reflection. And then the laser light alters its previous path by step. That's why we can see the curved light.
There are quite a few notches, so-called the grating, on the CD. When the light is passing through the CD, it will cause interference or diffraction. When the laser light passing through the grating, we will see the central bright light and the first bright light, and the second one like this. Now we make the experience. When the laser light vertically passing through the CD, we can see 2 points. And when the laser light passing through to CD, it's just like 2 gratings. We can see 4 points. When it's passing through 3 CD, we can see 6 points. We can use this principle to produce variety of image on the scene, like this. This is an symmetry image, and this is an unsymmetry image. We can use this principle to produce this hologram, but this is a symmetry image. How to do the unsymmetry image? We can let the grating, we can let the laser light passing through the CD, not vertically. Then the 2 points will have different distance from the central bright light. So use this principle, we can make the unsymmetry image. The base radius of the exterior of the lens should be the parabola. However, it is hard to make a lens such perfect. So the lens we usually get on the market is special parabola. You can try to spot the light on the verge of the special lens. Then you will find the light cannot focus on one point. This is what we call the special aberration.
Hi everyone, I'm here to show you a fun experiment. How to make the laser light in the solution disappear. Now I'll tell the truth. First, you need a colloidal solution. Why we use colloidal solution? Because the particles inside are big enough to have effect on the laser light. When the particles get energy from the laser light, will vibrate, and this vibration will cause power lines in the shape of a pumpkin, and the power lines will generate electromagnetic waves, if the path of electromagnetic waves are parallel to the aspect of our sight, we will see the path of the laser light clearly. Otherwise, we can see nothing. Thank you.
Diffraction of hair and interference of ruler. Have you ever thought how to measure up the radius of your hair? Ruler? No, it's not sophisticated enough. Here comes a tip. We can put one hair in front of the laser light. Then we will see the diffraction stripes on the screen. Now, measure up the length between the two darker lines and the distance from the head of the laser light pen to the screen. Finally, use the formula delta y is equal to lambda cos L divided by D, and we will get the value of B, which represents the width of the hair. In other experiments, if we want to know what the wavelength of another laser light is, similarly, we can use the formula again. First, we should have one laser light known of wavelength. Subsequently, use the same concept measures above to calculate the value B, which now means how far between two lengths of calibration. After that, use the laser light of the unknown wavelength, so the ruler, to show the interference stripes, and likewise measure the length between two darker lines and the distance of the path of the light. Eventually, use the formula to get the wavelength lambda. That's all.